Hello, welcome. This is Algebra 2. This is the review for Chapter 5, and here we are on Exercise 26, which is about a rectangular prism, and it gives us some information. A lot of people will probably solve this by guess and check, and that will probably be okay. But I'm going to show you how you can solve it kind of straightforward math ways. So we have a rectangular prism. And there we go. Okay, it's got a length, a width, and a height. And it tells us that the width is 2 meters less than the length. So it appears that we're meant to start with the length as our basis. So we'll call the length x, and the width is 2 meters less than the length. So the width is x minus 2. And the height, it says, is 1 meter less than the width. So that's, you could call that x minus 2 minus 1, or you might immediately recognize, oh, that makes it x minus 3, because it's 1 fewer than the width. And then it's about the volume. Okay, well, we know that volume for a rectangular prism is length times width times height. So for us, the volume is x times x minus 2 times x minus 3. And they tell us the volume is 30. So there we go. Now, it might immediately look to you like we're ready to solve because it's factored. However, factoring only works really when the equation is equal to 0. So we actually have to go through the very long process of unfactoring or foiling, and then moving everything over, and then factoring it again. So if we were to just engage in our favorite FOIL pastime, we end up with 30 equals x times x squared minus 3x minus 2x plus 6. So 30 equals x times x squared minus 5x plus 6. So 30 equals x to the third minus 5x squared plus 6x. We're doing great. However, not quite 0 yet. If you move the 30 over, you get x to the third minus 5x squared plus 6x minus 30 equals 0. Now, we are ready to use all of the tools we have so far. Rational zero theorem, and quadratic formula, and factoring, and synthetic division, whatever it takes to solve this. Now, of course, the rational zero theorem tells us that, let's see, our possible zeros, because we're interested in the constant term divided by the leading coefficient factors. It's nice that the leading coefficient is at least 1. So the numbers we should be worried about are plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 5 over 1. Wow, excuse me, 4 over 1 is ridiculous. Apologize. 4 isn't a factor of 30. Plus or minus 6 over 1, plus or minus, well, we got 10 over 1, plus or minus 15 over 1. That's a long list. I ran out of room. Plus or minus 30 over 1. All right. Now we're interested in the number of those that will work. And you can do substitution or whatever. And I'm going to tell you that x equals 5 works, because if you substitute in 5, you get f of 5 equals 0. Now, At this point, on this kind of problem, probably can just go ahead and write down 5 as the answer. But I'm going to keep going to go ahead and show the synthetic division that comes from it. So you get the 5 number in the box. Our numbers in front are 1, -5, 6, -30. The 1 comes down for free. 5, 0, 0, 6, 30, 0. So the factoring, and I realize we're really close to out of room here, the factoring makes 0 equals x minus 5 times x squared plus 6. And if you do any work at all with that quadratic, the quadratic formula, for example, you'll find that it doesn't have any real zeros. So this is the factored version, which means that the length is 5, the width is, it says 5 minus 2, so the width is 3. The height is 1 less than that, so the height is 2. Go back up top, look for units, meters, 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 and that's the answer. Please remember to put meters, that is, put units on your answers here. And thank you for watching.